So far, we have covered face recognition, which relies on photos or videos, and voice recognition that relies on audio recordings. In this video, we will focus on recognizing human activities, in particular with wearable sensors. We will look at different types of wearable devices, the types of sensors they are using, the approaches used for activity recognition, the applications that use it, and at the end we will discuss some data privacy aspects. The most popular and widely recognized wearable devices are smartwatches and fitness bands. They are worn on wrists and can have their own display or user interface, or they connect to the user's mobile phone. A smartphone, with its multitude of sensors, is often used as a smart wearable as well, as we will see in the following. There are many types of smart wearables: smart clothing, shoes, patches, glasses, smart jewelry, and so on. Let us first have a look at the many sensors that are integrated in a smartphone. Each sensor can have numerous purposes and can be also used for activity recognition. Accelerometers measure acceleration forces, whether caused by gravity or by movement. They can capture data in 1, 2, or 3 dimensions. Other sensors include a gyroscope, magnetometer. Some phones come with air pressure sensors, and, needless to say, phones come equipped with cameras and microphones. Some dedicated wearables include heart rate monitors that can measure heart rate and ECG depending on the electrode configuration. Another group of sensors measure galvanic skin response, which refers to the electrical conductance of the skin, which can be used to determine changes of moisture level, which is sweating. There are numerous domains where activity recognition with wearable sensors can be used. The one you are probably familiar with are fitness trackers, but these technologies can also be used in healthcare, elderly care, rehabilitation, gaming, or industrial and workplace safety. In fitness applications, wearables can track activities like walking, running, cycling, and even more specific exercises like push-ups or sit-ups. They often come with coaching apps, allowing the users to set and compare goals with their friends. They have models that count calories and can help with healthy living. In healthcare, wearables are useful for patients with chronic diseases such as diabetes, heart disease, or pulmonary disorders. They can be used together with coaching apps to better manage the health condition or for telemonitoring to warn about possible problems. Wearables can be used to measure sleep patterns or stress levels, and this information can be used in adjusting medical treatment. In mental health, identifying increased sedentary behavior or lack of regular routines may indicate depression or anxiety attacks. Activity recognition can be used in industrial and workplace safety to make sure that the workers are using correct postures and techniques. In elderly care, a very important aspect is fall detection, as this is a major risk to the elderly. Understanding routines like eating, sleeping, walking, and any deviations from them can help caregivers intervene early. This is called daily activity monitoring. Using wearable sensors also allows to locate people with dementia that may get lost, or to monitoring adherence to taking medications. In an example of a non-medical application, some wearables can capture motion and gestures for interactive gaming. When training the activity recognition model for a new application, the steps are usually the following. First, data is collected from users performing specific activities while wearing the sensors. Activity recognition can be attempted using only one type of sensors or using multiple sensors, which is called sensor fusion, and this can also be beneficial. Proper labeling is important if we are planning to use supervised learning. Second, data pre-processing includes noise filtering and data segmentation. 3. Feature extraction takes raw data and extracts specific metrics that best represent different activities. Then, using machine learning algorithm, a model is trained to recognize specific activities based on the extracted features. Finally, the model's accuracy and generalizability are tested against unseen data. If the performance is good, the model can get deployed in real-world wearable device for real-time activity recognition. Monitoring activities can offer benefits such as enhanced health and safety, but it also raises concerns around privacy, autonomy, and potential misuse of data. Do individuals know that they are being monitored? Have they given explicit informed consent? What data are being collected? Are all the harvested data strictly needed? How long are the data kept? Where and how secure is the storage? Long-term storage of detailed activity data increases the risks of potential privacy breaches. Are the data shared with third parties? For what purposes? Data may be sold to advertisers or used for other commercial purposes without the knowledge or consent of the individuals. Finally, who owns the data? Regulations, such as the GDPR, makes sure that questions like these are addressed. Continuous monitoring might make individuals feel pressured to behave in a specific way, diminishing their autonomy and freedom of choice. It can also cause anxiety or obsessive behavior in some individuals. Monitoring vulnerable groups such as children, the elderly, or patients requires special ethical considerations to ensure that they are not exploited or coerced into being monitored. Employers may use activity monitors to track employee productivity or health, which can also create ethical dilemmas around coercion and privacy. All these questions need to be addressed before activity tracking application can be used in a responsible manner. At the end of the unit, you will find several questions to test your knowledge. Here is one of the questions. What is a typical example of application of activity recognition in healthcare? Is it virtual reality training, assistance with shopping, elderly care, or protection against infectious diseases? What do you think?